Hi, today we're going to look at parallelograms and using coordinate geometry to help figure out where the intersection of two diagonals meet within a parallelogram. So here we have four coordinates, four vertices of a parallelogram. We want to figure out if we draw that picture in the diagonals, where do they all meet? So let's draw a picture. Now this picture doesn't have to be perfect. I just know I have to go back, I have to go up. That is negative 5, 5. I'm going to go over and up 2, 5. I'm going to go back 1, down 1, somewhere over there, negative 1, negative 1, and back 8, down 1. So here's your picture. If we connect those dots, we have something that looks like a parallelogram. We have A, B, C, D. Okay, great. Now, we want to figure out the intersection of the diagonals in this. So what do we know about a diagonal? Well, in a parallelogram, when we have diagonals, those diagonals, when they meet each other, they end up bisecting each other, meaning that we cut these into two equal parts. Okay, so I want to figure out what this location is. That location on this BD line is going to be in the middle to have two equal parts. This coordinate on the AC line has to be in the middle to have two equal parts. So we need to find a middle point of a line, or a midpoint. So we had a formula that we may have learned a while back for the called midpoint. That was taking x1, adding it to x2, dividing it by 2. Taking y1, adding it to y2, dividing it by 2. Essentially, we're taking coordinate, and just averaging the x's together, averaging the y's together. And we need to do that for both of these. So let's take a look at AC. The midpoint of AC, we're going to have my x's. I have negative 5 plus negative 1 divided by 2. And then we're going to do the same thing with the y's. We're going to say 5 plus negative 1 divided by 2. When we simplify that, you're going to get negative 5 and negative 1, which gives you negative 6. Negative 6 divided by 2 is negative 3. 5 minus 1 is 4. 4 divided by 2 is 2. Okay, that's good. So this was for AC midpoint. We need to do that again for BD. Why do we need to do it? I mean, this should be good if that's a parallelogram, but we want to double check ourselves. So putting in that extra effort just to make sure that we're correct goes a long way. So BD midpoint, we're going to say my x's, let's add them up. Negative 8 and 2. Negative 8 plus 2, divide them by 2. My y's, negative 1 and 5. Negative 1 plus 5 divided by 2. Okay, up here, we're left with negative 6 divided by 2. Again, negative 3, looking good. 5 minus 1 gives you 4. 4 divided by 2 is 2. And that's perfect. Because both of these are the same, I'm confident in saying that the midpoint of those diagonals where they meet is negative 3, 2. And that's using coordinate geometry within parallelograms using the diagonals.